Good afternoon. I'm going to try something different here and try to put myself in the corner of the video. There. Okay, it works. All right, so this video is a sort of a summary of all the factoring strategies we've done so far. Because very often when we're factoring a polynomial, we're going to have to use two or more strategies or techniques for the one polynomial to factor it completely. So I think it's a good idea to have sort of a checklist of factoring skills, techniques to run through every time you see a polynomial. So I've created sort of a flow chart for you to follow when you're trying to factor a polynomial, and you just follow the flow chart, and if you follow it every step of the way, you should be able to factor whatever the polynomial is completely and not partially. So, and keep in mind that these strategies are my strategies. They're my recommendations. Some of you who are more experienced at factoring may have other strategies, and so you don't necessarily have to do what I do or do it in the same order that I do. But I've done this for a while, so I highly recommend this. My first step is always to look for a GCF. And when I say GCF, I don't mean a GCF of some of the terms, 2 out of the 4 terms. I mean a GCF of all the terms. This is what I mean. Okay, so once you've taken the GCF out, you of course have a leftover. And the leftover could either be a binomial leftover or a trinomial leftover. I'm going to, just for now, not worry about 4-term polynomials. So just binomials and trinomials. Okay, let's say the leftover is a binomial. If the leftover is a binomial, we have several possibilities. 3 to be exact. The leftover could be a difference of squares, or a difference of cubes, or a sum of cubes. There's no such thing as a sum of squares. Okay, so difference of squares we know is a squared minus b squared, and that becomes a plus b, a minus b. Difference of cubes, a cubed minus b cubed, a minus b times a squared plus ab plus b squared. Sum of cubes, a cubed plus b cubed, a plus b times a squared minus ab plus b squared. And then once you've factored the difference of squares or the difference of cubes or the sum of cubes, always double check those factors, just to make sure that those factors are not also factorable themselves. Maybe there's a GCF hidden in there. Maybe the leftover is itself another difference of squares, something like that. Okay, so that's one branch, the binomial branch. Take GCF out, then the binomial is going to be one of these 3, or it could be none of them, in which case you're done. Okay, now the other main branch is, what if the leftover is a trinomial? Okay, so if it's a trinomial, you basically have 2 possibilities. The trinomial could be a perfect square trinomial. or just a general trinomial that is not a perfect square. If you have a perfect square trinomial, then it must be one of these two patterns, either a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. And these are patterns that you should have memorized. This one's a plus b squared, and this one's a minus b squared. If your trinomial is a general trinomial, meaning not perfect square, and factorable, this is where you play the game. And you split the middle term. And that's the 5-6 step process that we recently did. And then of course there is a possibility that it's prime, that the trinomial left over is prime, so you're done. And I should put that over here too, because the binomial left over could also be prime. Most of the time it won't be. Most of the time it'll be something you can do, the leftover. Okay, so let's do some examples of these two-step factoring polynomials. First, we'll do some binomials. Four x squared minus 64. So first, I check for GCF. There is one. It's 4. Then I check the leftover. Is it one of these? Perfect square minus perfect square. Yes, it's difference of squares. A is x and b is 4. So x plus 4, x minus 4. I double check my factors, make sure there's nothing else I can take out. And I make sure there aren't any like terms inside the parentheses. There aren't. So I'm done. Okay, next one is 3x cubed plus 81. Again, check for GCF. I see a GCF of 3. Take it out. I check the leftover. It's a binomial. Is it one of these? Well, it's not a difference because there's a plus. So the only possibility is that it's a sum of cubes. That's a cube. 27 is also a cube, so it is a sum of cubes. Now identify A and B. A is x, and B is 3. X plus 3. And then the trinomial factor is x squared minus 3x plus 9, according to the pattern. Okay, third one, 5x squared minus 15. I see a GCF of 5. Take it out. Leftover x squared minus 3. Binomial leftover, there's a minus, so it's either difference of squares or difference of cubes. 3 is not a perfect square, so it's not that. 3 is also not a cube, so it's not that. So this binomial must be prime. So there's no more factoring, further factoring to do. I am done. So this one is just one step. You take out the GCF and you're done. Okay, let's try some trinomials now. Okay, I look at my three terms for GCF and I see a GCF of 3. Take it out. Okay, leftover is a trinomial. If I play the game, I'll notice that the winners are 3 and 3. 3 and 3. So I can skip to 3 times x plus 3, x plus 3. And since these factors are identical, I now realize, oh, this was a perfect square trinomial. I could have just noticed the pattern and factored it that way, but this one was simple enough to do it using the game also. So the game applies to perfect square trinomials as well. So if you don't feel like memorizing the pattern for the perfect square trinomials, you actually don't have to, because if you can play the game and split the middle term, that covers all trinomials. Okay, number 5, we have degree 4 to start out. Degree 4. Which might be scary, a degree 4, but you'll notice that the GCF here is x squared. So when I take it out, the leftover will not be degree 4 anymore. It'll be degree 2. And I can play the game here with product negative 18, sum negative 7. The winners are negative 9 and 2. And since a is 1, I can skip to x minus 9, x plus 2. The full factorization is x squared times x minus 9 times x plus 2. And our last one, this trinomial with a GCF of 2. With a leftover of that. I need a product of, playing the game now, I need a product of 2, a sum of negative 1. Product 2, sum of negative 1. There doesn't seem to be any winners. If the product is 2, either the numbers are both positive or both negative. So 1 and 2 or negative 1, negative 2, neither of those pairs work because I need a sum of negative 1. So this leftover is prime. So I am done. It's just one step. For number 6, just like in number 3, it was one step after taking the GCF out. Okay, so that's pretty much all your factoring skills in action. There are different types of factoring techniques. There's the memorization type, your patterns. There's the recognizing GCF type. And then there's the process of the game splitting the middle term on those trinomials. It's a very good idea to be talented, skilled at all these different types of factoring scenarios. You don't want to be stuck because you've only worked on 2 out of the 3 or 1 out of the 3 techniques, hoping that that's enough. You want to be prepared for anything. All right? Okay, so next time the video will involve taking these polynomials and putting them inside equations so we can solve these equations. See you next time.